Hi guys, and welcome to another live lesson. Today we're going to be looking at how we can operate with surds. We're going to start off with just some of the basics, pen and paper. That's something you'll need for today's session. We'll also need to be able to log into a website, hbkportal.co.uk/mwb/home. Now, before we go on any further, I want to quickly just review some of the things that I discussed in our last live lesson on surds. Now, with this, one of the things we were able to do is simplify a surd. We were able to identify two numbers that could multiply together to give me the number underneath the square root, in which case the condition on that was that we were after one number that happened to be the highest square number that went into the surd, i.e. in this case 4, and then 5. Now, one of the things you can try on your calculator is if I do the square root of 20, I will get something known as an irrational number, very long decimal, but I will get the same irrational number that from doing the square root of 4 times 5. I'll also get that same answer if I did the square root of 4 times by the square root of 5. Now, all of these have exactly the same answer. However, if this was a non-calculator paper, you'll notice that there are certain things in that last line that we can work out. That the square root of 4 is 2. So we end up with the square root of 20 being able to be simplified down to 2 root 5. Now, in order to rehearse some of the things that I discussed in that last video, one of the things I'm going to ask you to do is now do a quick matchup. So we've just seen how the square root of 20 can link to 2 root 5. What I'd now like you to have a go at is the remaining 4 items and match it up with the answers on the right hand side. You've got 2 minutes. Off you go. Okay, and welcome back. So, one of the things that we'll look at is now the answers of each of these questions. So, starting off with the square root of 32. 16 is a highest square number that will go into 32, so we can write 32 as being the square root of 16 times by 2. And if we then think, in this case, that if it can be written as the square root of 16 times the square root of 2, then we can take the 16 square rooted on the outside, and we get 4 root 2. So the second question there will simplify to give 4 root 2. Doing something similar with root of 200, that can be split into the square root of 100 times by the square root of 2, and obviously the square root of 100 is 10, so we get 10 root 2. Thinking of the highest square number that goes into 50, it will be 25, and the square root of 50 could be written as the square root of 25 times by the square root of 2. The square root of 25 is 5, so this then matches up with 5 root 2. And then finally the last one by default, but let's go through that. The highest square number that goes into 98 is 49, so the square root of 49 times by the square root of 2 will have the same answer as the square root of 9, so we get the answer 7 root 2. So if this is what we had been discussing in our previous lesson, what is it that we'll be able to do by the end of this lesson? Well, here's the kind of extreme question that I could give you in today's learning. However, let's think about where we can start in order to be successful. Well, let's think about some of the basics that we might have done with algebra. That if I've got a plus a, that will give me 2a. If I've got a plus 2a, that will then give me 3a. And if I've got 4a plus 2a, that will give me 6a. So at this point, we've identified that we can simplify algebraic terms by simply collecting like terms. And even if we then added in an extra letter, we can only simplify the things that are the same. So I can only simplify 4a plus 2a simply because they both contain a in it. B, on the other hand, represents a different number, so it's not something that I can collect together. The answer to this would then be 6a minus 3b. However, the question would be, where have all the surds gone? So let's think about how we can introduce them. Now, if a and b could represent any type of number, what if a was root 2 and b happened to be root 3? Can we simplify it? Well, making the substitutions, we get something that looks like this. And if I said 4 root 2 plus 2 root 2, and then I take away 3 root 3, hopefully you can identify that 4 root 2 and 2 root 2 can be simplified to give me 6 root 2. I then can't simplify 6 root 2 and minus 3 root 3 simply because the square root of 2 and the square root of 3 are different numbers, and therefore, like a and b, cannot be simplified. So thinking of some success criteria then, at this point we can then say that we can simplify surds in the same way as what we have done with algebraic terms, and surds are just the same. So thinking about how we can model this, and for you to then have a little go and a practice, on the left hand side, let's just quickly fly through some of these. So 6 root 2 minus 3 root 2, this can be simplified to give me 3 root 2. 3 root 5 plus 2 root 5, well, that can simplify together to give me 5 root 5. However, with question 3, we've then got the problem of the fact that the square root of 48 is not in its simplified form. So now thinking that the square root of 16 and the square root of 3 could multiply together to give me the same answer, I can write the square root of 48 as being the square root of 16 times by the square root of 3. And there we go. So I can write this as that problem. So the square root of 48 is the same as the square root of 16 times by the square root of 3. The square root of 16 is 4, so now you can see that by simplifying that first fraction, we've now got it in terms of root 3, and 4 root 3 minus 3 root 3 is then 1 root 3, or just root 3. Moving on to the last one, the square root of 20, same thing again. I'm going to want to be able to simplify this surd before I can add it on to 8 root 5, and hopefully the surds will be the same for me to be able to do that. Well, earlier in the video we saw that the square root of 20 can be simplified to be 2 root 5. So 2 root 5 add 8 root 5 is 10 root 5. Okay, so now you've had a quick look at how I would answer some of these questions. On the right hand side, you've got your own go You've got 3 minutes in order to have a go at these questions, and we'll return back after 3 minutes to go through the answers. Okay, so let's go through these answers then. So first of all, I'm looking at the first one, 7 root 5 minus 6 root 5, and I can see that they both have the common term there. So 7 root 5 minus 6 root 5 will give me 1 root 5 or just root 5. Moving on to the next one, I can see that both of them contain root 7. So 11 root 7 add 10 root 7 will then give me 21 root 7. The next one, on the other hand, does not contain the same surd. So we need to be able to think about how we can simplify the square root of 28 into its simplest form, and then see if it contains root 7, in which case we can then add them together. I can split 28 into 4 times 7, and there's the clue that 7 appears within one of the numbers, so that is my way forward. And 4 just happens to be the largest square number that goes into 28. So writing this as the square root of 4, the square root of 7, add 5 root 7, I can see here that this bit simplifies to give me 2 root 7, and I'm adding on 5 root 7, which was the second term, and 2 root 7 add 5 root 7 is 7 root 7. Now, in a similar fashion to the next question, I've got kind of like a clue, the fact that the number's got to have 5 underneath the square root, and in this case we can split root 45 into the square root of 9 and the square root of 5, of which the square root of 9 is 3, so I've got 3 root 5. Taking away 2 root 5, and I get 1 root 5, or just root 5, as being the answer. So we've now gone through each of these different questions, and I'm hoping that that's kind of given you some confidence with this style of question. However, one thing I am very conscious of is at this point that we have only dealt with how we can add or subtract. So at this point, we need to move on to our ability to be able to multiply or divide. So with this, let's have a look at a couple of questions. So returning to my drawing pad, and the square root of 2 times by the square root of 2. Now with this question, it's almost like the reverse of a simplifying question. In this case, I've chosen the surd to be the same, but I could have chosen anything, to be honest. I could have chosen root 2 times by root 3. The clue with this is that we can combine surds together in the same way as what we did when we simplified. So I can write this as a single surd of 2 times 3, which is then the square root of 6. But when you have the same surd, let's see what happens with this. The square root of 2 times the square root of 2 could be written as the square root of 2 times 2. And that's the square root of 4. But notice how the fact that a square number has appeared underneath the surd, we've now got this square root of 4, which is now 2. I'm not saying that in this case this would also happen with division. So let's have a look at the square root of 2 divided by the square root of 2. Well, I've got a number divided by itself. So in this case, the answer will always be 1. But if the surd happened to be root 2 divided by the square root of 3, I can't simplify this because they are not common. So what does this then kind of tell us? And would you be able to predict what would I get with each of these examples? So what if I had root 3 times root 3? What if I had root 3 divided by root 3? Well, the answer to the first one would be 3, and the answer to the second one would be 1. So let's have a look at a few other examples and build up a bit of confidence. Square root of 5 times the square root of 5. 5. 2 root 5 times by 5, root 5. Now using the commutative law, we can multiply in any particular order. So 2 times root 5 will just give me a very long decimal. However, if I chose to do root 5 times root 5 first of all, I would get 2 times the square root of 25. And obviously the square root of 25, 25 being a square number, would give me 5. So 2 times 5 is then 10. What if I had root 5 divided by root 5? 1. What if I had the square root of 14 divided by the square root of 2? Through partially simplifying the square root of 14, we would get square root of 7 times by the square root of 2 divided by the square root of 2. And BidMath says that we can multiply and divide in the order that they appear. And here I can actually do root 2 divided by root 2 if I wanted as well. And that would then give me 1. So the final answer is just root 7 because it would cancel out. So let's have a look at some more questions like this to build up a bit of confidence. And we'll have a my turn, your turn session. So looking at these questions then, starting off with the first one. Let's think about how we can do root 2 times by root 3. So given root 2 multiplied by root 3, we can write this as a single square root as being the square root of 2 times by 3. The second question said 3 root 5 multiplied by 2 root 5. The commutative law says that as long as they are all being multiplied, then I can actually change the order and work it out in whatever way. So 3 times 2 and root 5 times root 5. I've chosen to link the multiplying numbers together and then also the surds, because now I can work out the fact that 3 times 2 is 6, but root 5 times root 5 is 5. So I get a nice easy answer of 30. What if the question then involved brackets? Now in this case, the square root of 3 multiplied by 2 root 3 add 4. Now from another video, we saw that when we expand brackets, whatever's on the inside of the bracket gets multiplied by that which is on the outside. So multiplying root 3 by 2 root 3 and multiplying root 3 by 4, I will expand out the brackets. So 2 root 3 multiplied by root 3. And then my second term is 4 root 3. So in this question, I can simplify this because root 3 times root 3 is 3, and 2 times 3 is 6, and 6 plus 4 root 3. I can't simplify this question anymore because this has root 3 in it, and the other term doesn't. So finally the last question then, number 4. What if I had the square root of 20 add 8 root 5 divided by root 5? Now here I'm looking for either both of the terms on the top to have a common factor, or in this case for me to be able to simplify the numerator and for me to then combine the numerator together. So earlier in the video we saw that the square root of 20 could be written as 2 root 5. Add on 8 root 5 and divide by root 5. Now every single term in the numerator has a common term of root 5. So cancelling out root 5 with the denominator, because it was common to all terms, I've only got 2 add 8, which is then 10 as being my final answer. So here you've seen how we can simplify surds, whether they are being added, multiplied, or even divided in this case. So what I want to do is give you a few moments to be able to have a go at some questions yourself, and for me to then go through the answers in about 4 minutes' time. Here are your questions. Please complete the ones on the right hand side with pen and paper. Okay, now although the first three questions were exactly the same as what I'd gone through, not having the working out in front of you to be able to simply copy hopefully meant that you managed to get the same answers as what I did. The last one though is one that I will go through, and obviously with this we will have the question root 50 minus 2 root 2 all over root 2. So simplifying this part first of all, because the square root of 50 is the same as the square root of 25 times by the square root of 2, which gives me 5 root 2. So having simplified the square root of 50 to be 5 root 2, now let's rewrite this whole problem again with 5 root 2 instead of root 50. So 5 root 2, take away 2 root 2 all over root 2. Now in the last example, I actually cancelled out root 2 as a common term to everything in the numerator because I was dividing it by root 2. What if I didn't do that in this case until the last step? Well, 5 root 2 take away 2 root 2 is 3 root 2, and then I'm dividing it by root 2. Now if I'm timesing by root 2 and then dividing by root 2, you can then see that this will cancel out and give me 1. So the answer is then 3 as being the final term. So we've now gone through how we can add, subtract, multiply, and also divide. And the key success criteria for this last bit mainly involved our ability to be able to collect like terms and then also multiply it successfully. Now I'm going to move over to a piece of software that I left in the description, which was the MWB website. You can see the link is just slightly off screen at the moment, so just bringing this down, you'll be able to see that it is hbkportal.co.uk/MWB/home. And I've Googled, I've searched for surds, and we are focusing on operating with surds. There is a single star question which will basically bring up one question at a time, and if you select the 1 star button, it will then keep refreshing it as many times as you like. Selecting the answer button will then reveal the answer. Moving on to 2 star, we then have questions that get progressively harder, as will the 3 star, 4 star, and 5 star based on today's lesson. I'm going to focus on all stars so that if you haven't got the ability to open up a separate web page, then you will have all of these questions to now complete. If you have any questions, then by all means, please reach out to me in the dialogue box of YouTube, or if you happen to have me on Facebook or Twitter, then please do post any questions. Otherwise, you have 5 minutes in order to have a go at these questions and see how far you can get. Okay, 1 more minute. Okay, so let's go through the answers. So for the first one, we can just simply add the 3 and the 4 together, so it give me 15 root 3. Moving on to the next one, we need to simplify the square root of 32. So that'll be root 16 times root 2, which simplified down to give me 4 root 2. So 4 root 2 add 11 root 2 would then give me 15 root 2. Please mark this as we go along. Although we can't really do too much else other than combine this into a single surd, the square root of 2 times the square root of 11 will give me the square root of 22. With this one, we can split this up into root 3 and root 5, so although neither of those are square numbers, the whole principle is that the root 5s will then cancel out, and it will just leave me the root 3. For this, we need to simplify both the terms in the numerator first of all, and then I can divide it by root 3, and it would then give me 5 root 7. Same thing with this one, expanding out the numerator first of all, and then simplifying that down as much as possible, we should find that it contains root 3, in which case we end up with a nice easy answer of 6 root 5. So throughout today's lesson, we've been exploring a range of different skills that relate to how we might operate with surds. But it was at the very start of the lesson I outlined one of our kind of extreme questions that we're aiming to try and achieve by the end of today's lesson. This question involves not only our ability to be able to simplify surds, but also how we operate with them as well. So as a way of just measuring how well we have done, let's just quickly think about how these skills that we've picked up in today's lesson go to answer this extreme question. So with this then, let's pull up the sketchpad, and we've got the square root of 112 plus the square root of 14, all divided by the square root of 7. Now at the moment I'm fairly good with my times table, so I know that the square root of 112 is the square root of 16 and the square root of 7. Each of these need to be within their own square root, so I don't forget that they are that has the same value as the square root of 112. And likewise with the second one, that this can be written as the square root of 2 and the square root of 7. So again, although this one doesn't follow the whole principle of, oh, I can simplify this, we do now see a common term of root 7 within all of these problems. So let's rewrite this, simplifying where we can. The square root of 16 is 4 root 7, and then I'm adding on root 2 root 7, and then I'm dividing it by root 7. Now because they all have that common term of root 7, I can cancel it out, in which case I'm left with 4 plus root 2. So a nice easy answer for what was a kind of an ugly representation of a number. So 4 root plus root 2 is what we would go with there. So we have now got to this point where I'd like to finish the session by looking at an exam question. And this exam question is very similar to what you might get within a past paper. They're not too difficult, but let's see how what we've learned today will translate into an exam style question. So Just waiting for my iPad to refresh. And here is the question. So in this case, we've got root 5 multiplied by 4 plus root 5. And each of these two questions that we've got on the screen at the moment are worth 2 marks. So in this case, I'm going to expand out the brackets to be able to simplify. And this is where I'm going to get my first mark from. The first term that I get is 4 root 5. The second term, root 5 times root 5, I will leave it in that form for now. But obviously if this was worth 1 mark, the second mark has to come from being able to simplify it. So 4 root 5 is in its simplest form, but root 5 and root 5 aren't. So I can simplify this to be just 5, and that's where I get my second mark from. For the second question, we need to use FOIL, claw method, the grid method, however it is that you want to be able to expand out brackets. But with this one, I've got the product of 2 expressions. So expanding it out, 6 times 4 and 6 times root 2. Let's do that bit first. 6 times 4 is 24, and 6 times root 2 is 6 root 2. For the next bit, I need to multiply everything in the second bracket by negative root 2. So negative root 2 times 4 and negative root 2 times root 2. So I then get minus 4 root 2 and then minus 2 root 2 times root 2. Simplifying as much as I can here, I can simplify the middle 2 terms. This would give me 6 root 2 minus 4 root 2 is 2 root 2. But we'll also notice that I can simplify the bit on the end. And root 2 times root 2 is 2. So remembering that I'm taking this away, now I can see that again I can do more simplifying, and 24 minus 2 is 22 plus 2 root 2. So this is how we can get all of the answers, all the marks to these exam questions. Now I hope that this has been fairly useful. Again, another live lesson on a slightly different topic, and tomorrow I'm hoping to continue with this by looking at the last in the sequence of lessons relating to surds. Tomorrow afternoon we're going to be looking at how we can rationalise the denominator, and this will basically complete our full set of skills relating to surds. Thank you very much for watching. Thumbs up if you liked it, subscribe if you loved it, but by all means please feel free to continue to use the software at hbkportal.co.uk/mwb/home to get some extra practice with any of the topics that I'm covering in the video. See you next time.